Okay, lag check. Ooh, wow, it's like a 30-second delay. So I just now saw me set that down. So anyone who sends me messages during the live stream, A, I got to turn around and look at my monitor to see messages, and B, there's like a 30+ second delay. So I may or may not be ignoring you, but that's what it is. Okay, so first disclaimer, not intended for children. Yeah, I say a lot of things I shouldn't, so you've been warned. So this is my Prusa MK3, and lately it's been jamming filament. I've taken the nozzle out, I've cleaned it completely, and it still does it. And the interesting bit is, it ejects just fine. And when it ejects, there's a little knob on the end of the filament. And if I just clip the knob and just reload it without changing anything, then it extrudes again. So my guess is something in the filament path. My guess is in the filament path there's a step, like the PTFE tube came apart, and when it retracts the filament, it solidifies, and then when it goes back down, it jams on that step. So we'll figure that out. Also, I just sort of have a whole pile of parts that are upgrades for it, including the MK3S Plus parts that I just haven't gotten around to putting on it because honestly it's a pain in the butt to get out of the lath enclosure, which I have a fix for that too. So, you know, they weren't needed. They're just sort of, hey, when I get a chance. So that's what's going on tonight. So first things first, those that watch Twitter, I just sort of snipped the wires. And everyone's going to go, oh my god, no, why'd you do that? It will be explained in due time, I think. So first off, I'm going to get all the loose bits off and put them someplace safe. And bring in my pile of parts. So I got a box top to put my outgoing parts and a box to do my incoming parts. So I have all the new MK6 parts, or sorry, the 3S Plus parts. My buddy was nice enough to print some for me since my printer is kind of SOL. And some of them, like this piece, and this piece are all done in polycarbonate, so I don't have to worry about it melting and warping on the hot end. And for those that haven't seen the S Plus parts, this is the little fan shroud, and it now just sort of slots into the hot end cooling shroud, versus there was a screw here, and I think like the far edge was just either hanging in space or got put together with another part of the assembly and was just kind of flopping in the wind. I apparently kind of owe my buddy a new bed. So this discoloration here is actually part of his textured sheet. He apparently just didn't put enough glue stick down to keep this from permanently adhering to the bed. So for those of you who have not printed with polycarbonate and are going to print with polycarbonate, lots of glue stick. Apparently it's a real pain in the butt balancing act because you need enough glue stick so that it doesn't rip your bed apart, but not too much because otherwise the corners like to peel and warp. So that's that. That's my upgrade. These parts here are the upgrade for power. I have a nice copper E3D block and a titanium heat brake. Some grease for bearings, some bearings. The thing on the bearings, I'm not replacing all of them. but one of the bearings in this axis, I think that's the X, every once in a while had a weird rattle to it. So I was gonna, when it's all apart, I'll check those out and deal with that. Here's the super pinda and a new extruder stepper motor. So one thing I noticed when I was printing desiccant containers, basically it's a print with a lot of little retracts really quick. The motor was getting hot enough that it was starting to melt that filament. That particular roll of filament's been a pain in my butt. So part of the problem is the filament, but this motor tends to run a bit hot for my taste, and this supposedly runs quite a bit cooler. So I'm going to swap that out. And then just some consumables, a new sock. I'll check out the nozzle, I'll probably clean it. I don't think I'll replace it. I also got the new bed clips. I already did the nylock upgrade to the bed so you can perfectly level it out. Unfortunately, I'm going to have to redo all that leveling once this is done. And I think that's it for upgrade parts. So, time for tools. Where do I want to start? So, I need to take all this loom apart. One to feed the wires for the new stepper and the new super pinda. So, I think I'll start there. I think these are all 2.5s. Yep. Still streaming? Looks like it. Cool. If the stream just sort of abruptly cuts out, probably not my internet connection at this point. My new provider is much better than my old provider, but I've been having some issues with the Pi that I'm sourcing my stream from. I rebooted it, and since I rebooted it, it seems to be fine, but never had this issue before, and not fully sure why it just suddenly started doing it. So if I all of a sudden disappear, as soon as I notice, I'll restart and get going again. So I need a bunch of little containers. I have a bunch of little containers. Just try and keep some of these parts together as I go. Oh, I should have brought up the Prusa website for the assembly guide. Stuff's pretty straightforward, but they have a really nice assembly guide, so versus guessing, you can just sort of look. Okay, what else do we got here? Okay, a lot of wires. I need my nippers. Nip, 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 nip. Huh. So what I'm noticing is the mount for this cable harness is loose. I was not expecting that. Just look how much printing string or filament remnants there are on the printer. Okay, so that up that way. do that first. So I snipped off these wires, and there's a bunch of people going, no, all over the internet. But the reason I did that, let's see if I did that in frame. Yeah, it should be in frame. So I have this little pile of parts. So my plan, this is a Molex Minifit Junior. They're good for about 9 amps a pin, and I think the total power supply on this is less than 10. So there'll be about 5 amps per pin for the heater, for the bed heater, and then the P-good signal. And that snaps into this bracket, which I'm going to mount right there. So this will go in there like that. The wires in the end. And then the mating cable will be on there. So the next time I want to take it out of the lac enclosure, it's just a matter of pushing the clip and pulling them apart, versus trying to get in there with a screwdriver to deal with all this. So I have quite a bit of excess on these. So I'm trying to decide, do I trim them down or leave them? I think I'm going to leave them. That way if I need to move it around, I can. And I need some pins. This is the, well, now politically incorrect term, female end, which takes male pins. So I don't need these pins yet. These are the female pins. Males. So I'm guessing the correct term would be plug and socket. This would be the socket, and these would be the plug pins. Yeah, I'm old. Male and female just works so much better in my brain. Wire skimmers. And I'll probably end up soldering these as well before I'm done. So I'm just going to cut these flush like that. Split the cable. That little itty bitty bit there goes into the pin like that, and then it gets crimped on. Now, if I didn't royally screw this up, these pins should work on this wire. If I did royally screw this up, these pins won't work on this wire, and I will have to wait to power this on and test it until I can order new pins and a new style connector. I do not have the exact proper crimper for these pins. I do have this Radio Shack. Yeah, Radio Shack crimper that I've had for, universal crimper that I've had for many, many years. It works. Ooh, no it doesn't. It usually works good enough. The official crimper for these is quite expensive. That's the main reason why I don't have one. So let's grab some solder and a soldering iron. This little guy is I think a Chinese knockoff of one of the Hakko ones. It's gonna get hot fast. Just uses these cartridges. Works pretty good. I've actually used this to replace my paste snapback for most things I do on the small end. For big stuff, the snapback's just better, mostly just because of this heating capacity. You know, it just can put more watts out into a wire or whatever you're doing. But for this little stuff, this works pretty good. I'm just putting enough solder on there to compensate for my lack of a proper crimper. Okay, that's one done. Time to do number 2. Once I get number 2 done, I can have the moment of truth and see if these actually fit into the body of the connector. Watch where you put your soldering iron. That's going to make that kind of difficult to drink now. Yeah, that was a bummer. Give me 1 second here. I'm going to polish that off, I think. Empty enough. Okay, back to this. Okay. 2 out of 6 pins done. There's pin 1. So the way they count these is 1, 2, 3, 4, 5, 6, I do believe. Not my doing, but there's 1 rib, 2 ribs, 3 ribs on this side. I think I'm going to make pin 1. How's this? This is going to go like this. I'm going to make pin 1 be plus. Uh-oh. So the way these work is you push them in and then they supposedly just sort of snap and lock. And I'm not getting any snap and lock action. One, right pins. I wonder if the jacket on the wire is just too thick for... Looks like it's going in all the way. Oh, I heard it. There it goes. So it must just be the jack. It's a little oversized. So give it a little tug, make sure they don't come out. There's 2 of 6 done. Okay, next 2. Yeah, I like that. I almost feel like this pin is the wrong gauge. Yep, it is. Boy, that one's ugly. But solder should take care of it. Okay, that should be good. That should be good. snapped in here. And this stream is going to become me fighting with getting wires to stick into Molex mini-fit connectors. So what I'm doing is just trimming off some of the excess solder drips, more or less. Theory being that is what's causing this to not be able to get all the way down and in and snap into place. That one's not in. Why won't you lock in? Too good for your home? What was that? Oh, that was Happy Gilmore. Well, I managed to spear the insulation right there, but I think overall it's solid. So the last one, this one should be much easier. Those other wires were a bit on the large size for... I think the wire itself was okay for the connectors. I can't remember what the... Well, A, I can't remember what gauge those connectors are good to, and B, I have no idea what gauge wire this is. But the insulation was so big, it was causing me issues getting it into the proper spot. Where these guys are quite a bit smaller and should pose no issue whatsoever. Oh, and they solder so much faster even too. Get this little solder booger off the back. Cut these insulation retainer wings down just because they're a little too big for this jacket of wire, and then give them a quick smoosh. Like so. And repeat for this side. Perfect. And with that, I'm done with soldering for, well, at least right now. And so, trim this guy. Trim that guy. And give him a crimp. Now these should just, I want to say drop in. There should be no restrictions to locking these in. Yep. Right in. Now the black wire. So there is that. Next up, I got a insertable frame nut. I'm trying to remember how these. Oh, just like that. And then I have this little 3D printed piece, which I need a different wrench for. Was that 3mm? Nope. 4mm. Yep, 4. So this is an M6 flathead by 12? Yeah, 12. Uh-oh. I had a miscalculation. This T-nut fits up into the groove a little bit, and this boss in the back of this fits down into the groove. And I miscalculated how short, or tall, or whatever you want to call it, the two need to be. So I need to make this little boss shorter. If I had a working printer, I could just print another one. I don't have a working printer at the moment. Honestly, a couple swipes with sandpaper should be good. Yep, so now it's locked on there. Okay. Take that off again. A couple more swipes just for good measure. I have a tool for that. Take that burr off, take that burr off. There. The bud. So now this just fits through the back like that, and I gotta figure out where I want to put it. I'm thinking right about there. Yeah, that looks good. So that's locked on, that locks in there. And then once I do this same thing to the other side, the power cord will plug in there, and the next time I need to get out, it's just a quick unplug. Done. Electrical tools. Here, shouldn't need the crimpers, probably need wrenches. And I moved the rest of that out to the lack enclosure where this lives, so I can do those repairs or those modifications out there instead of trying to haul the whole thing in here. Get my feet up where they go. Okay. That's pretty good tension. Oh, I gotta take that off. So I'm going to sort of work from the bottom up. So the first part to deal with is the heat bed, or the heated bed. So take that. Take that. There's a tensioning screw right there. Can I take this apart without dinking with that? So I particularly like the Bonduras brand of Allen wrenches. I got a free set at a trade show once, just like a little mini set, and they don't seem to round out their corners as fast. I mean, if you really reef on them, you're still gonna round a corner off and then have to trim them, but they definitely stand up better than most of my other sets, which aren't anything fancy. They're just random Chinesium sort of. Chinesium's not a fair term. They make good stuff, they make bad stuff. Just most of the stuff that at least I buy from China, I'm buying it because it's cheap. So, not the greatest quality. Okay, that's off. So, next, I'm going to take the rails apart. And of course, I'll have my clippers out here. So the goal of my current activity is to put in those and those, and possibly some bearings if I need it. I will also relube the current bearings as part of this activity, if they are in good shape. So, in theory, since I wasn't having problems with this axis, there's no reason to replace these, but it's a part, so they're getting replaced. And I can clean them. There's quite a bit of fuzz. So now, the interesting part. If you're not careful, you can knock the bearing balls out of these guys. So I'm going to out typically, well, you'd have to really try to knock them out on the way out. It's the way in where you typically do the damage. So there, that's out. And I'm just going to degrease or wipe all the schmoo off of these. And carefully set them off the side here. So, I don't know if you can see this, but I've changed out the spacers that usually are here for a nylock and a screw. And the theory is you just slightly loosen up the nylock, and then you can use the screw head to adjust this position with respect to this guy. So you can sort of, if your bed's tipped one way or the other, you can raise this corner and lower that corner, or vice versa, to get it back to true. The screw that mounts right in the center still has the spacer. So this is the 0 reference point, and then you can tweak, you know, these 6 bolts up and down independently to get everything nice and flat. What's the best way? Oh, I'm gonna have to take it apart. That makes me a bit sad. Let's see, where are my spanners? Small spanners. Oh, hey, I found my tapered reamer. I was looking for that earlier. So I think these are 5.5s. Let's see, 5. Nope, too small. 4.5. 4. Oh. It looks like I don't have a 5.5 in this set. Well, I probably have it in a laser cut. Way too big. So these laser cut wrenches I got from Great Britain, and some of them, I think they're for a British thread form. So they work, but they're slightly undersized or oversized. Aha! It was over in my other kit of parts. Yeah, so I just use that guy. Reamers. So all I'm doing here is going around and loosening off the nylocks. This is going to be so much easier to do if I just take the heated bed off. Downside to this is I'm going to have to fully recalibrate the bread. But, oh well. And those are probably 2mm, I do believe. Yeah, it looks like they're 2s. Oh no, those. Not English, are they? Nope, not that. Oh, fun. So it looks like I chowdered that's the head on that center screw. Much chowder. Another unexpected turn of events. And this is going to suck because now I'm going to have little metal shavings on a magnetic bed. So cleaning those off is going to be entertaining. Yay, left-handed drill bits. Hot. Ooh, hot. Okay, well that cools. Hopefully that's the only one I have to do that on. But I'm not holding my breath. The other ones are easier. Since I have the nylocks on the bottom, I can actually get pliers underneath them and give them a spin if I need to. Okay, that one's loose. That one's loose. That one's loose. That one's loose. And that one's loose. So that is off. Slide that back through that way. So there's one of the spacers. Put on with that. Okay, let me grab a nut driver. That was 6. I have a 5. I don't have a 5.5 in that set. None of that. one of my billions of sets of screwdrivers should have a 5.5 millimeter socket. I'm not seeing it at the moment, so out comes the bin of random sockets. Actually, what size is that? Oh, that's English. Those are Thorax. English, English, English. Seconds. .5, nice. These are on loose enough, yeah. Just do that. So now what I'm going to do, just very carefully put these on and make sure there's no, best I can say is weirdness. Don't make any crunching sounds or anything along those lines. Or slide smoothly, then all of a sudden get rough. That's another sign of something bad has happened to your bearing. And make sure you don't punch a ball out the bottom. I'm happy with that. Yeah, no weird rattles in those, so I'll leave those be. So now we need our little new kit of parts. So what you get is a little clip, some screws, and some more nylocks. So the theory is, when this is tightened all the way against the plate, everything's good to go. And you don't have to worry about... The problem with the U-bolts is if you tighten them down too much, you crush the outside of the bearing, and then those little balls... inside here there's little rolls of balls, and there's actually an oval track they run in. So they run along the rod, then flip back into the body and run through a track to return. So if you crush the outside and squeeze those balls, they can't roll anymore, and then they'll basically, a roll of balls will just jam up. There's also, so this bearing has four rows of balls. One set here, one set here, one set here, one set here. The instructions are also specific that when you put these in this plate, you do not want a row of balls lined up like this. You want it turned such that the balls are on 45s to the plate versus perpendicular and parallel to the plate. So gotta make sure you clock your bearings correctly. So this just sort of goes in like so. Which side was down? I see the indent from that center post right there, so this side was up. And I threw all of these in this tub along with one of the screws. There it is. one of the screws for the cable, or the belt, and the belt one was a different length, so throw it out. So, little clip. Ooh, the little clip doesn't clear. There it goes. So the screw heads are thicker than the body of the bearing and the clip will allow, so you have to sort of thread them through to get them started. Nylock. Nylock. And this is where you need more hands. Check my clocking. Right there looks pretty good. Now in theory you can't over tighten these anymore, but I'm still just going to sort of go tight and then a little bit more, like not a quarter turn more, but just tight. I don't know a better way to putting it. So that one's all done. So bearing is inside the cutout, it's contacting that on both sides, and the clip's fully tight. Now we just got to do it again a bunch more times. I'm putting it on the right side of the plate. Kind of a bummer. Put one on the wrong side. Take it all apart again. It's not like I'd ever do that. There's printing debris down on top of my stepper motor. Again, I'm just tightening one of these up. Which preloads the bearing a bit, but I can still spin it. And then I'm just eyeballing that the balls of bearings are at 45s to this plate. Which is honestly a bit more difficult than one would think. There's lots of, at least to me, there's lots of shapes in there that plays tricks in my eyes. And it's like, that looks like 45, and then you shift your angle a little bit and you're like, no, that's not 45. Well, over tighten that one a bit. I have an unintentional built-in torque wrench on this Allen key because the end is a bit schmooed. Okay, last one. One of the downsides with the Lime Stream, no music. I usually have music in my shop, just any sort of background noise. I can't do audiobooks or YouTube videos because I pay too much attention to them. But usually I got some sort of music going on. You know, honestly, it's typically just one of the local radio stations. YouTube does have royalty-free music for use on YouTube. So maybe I should go dig through that and make a playlist that I can just run while doing live streams. Only downside to that is, I'm guessing without fail, at some point I'd do a stream or something with what I thought was that playlist and instead have some other playlist running, and then, well, it doesn't take much in YouTube to get everything banned. So for now, no background music. Okay, just double checking that my bearings are on a 45, which they look to be. I'm going to go through and just nip up the back of all these guys. Again, with this new design, in theory, it's not possible to over tighten them. So if you look at them, they're flat plates, so it spreads the force over the entire bearing, and two, they're not perfectly fitting, so as you tighten that sheet metal around this bearing, it's going to try and turn these corners into a smooth sheet. So there's a little bit of give in there. I mean, it's not, if you're really cranked down on them, yeah, you're going to cause problems, but I'm assuming they put some thought into these parts and got the bends such that you don't have to worry about that anymore. So I'm going to set this aside for a moment. And the next piece to get swapped out are these. So these are the old brackets on here. And the rod's sort of clipped in a little bit. And then the zip tie was just to keep them from popping out if you happen to grab it by the, well, A, if you grabbed it by the plate and pulled, and B, you know, just time and vibration and movement. Ooh. The reason I'm going ooh is that one's spinning. How? Ooh. That's going to make getting that guy out very entertaining. So the plastic nut jammed on the thread, or I'm sorry, the nut inside the plastic jammed on the threads and then spun. So I don't know exactly what I hosed up in there, but that one's boogered. It's gonna take some ultraviolence of some sort to get that removed. So what are these? These are M3 by 0.5. And the reason I'm looking for that is I need some more nut certs to put in the new parts. And I need to retrieve the nut certs out of the old parts, which I'm trying to do right now. So when I tighten the nuts up, it actually pulled them into the plastic a significant amount. So I'm going to thread this in a bit, give it a whack with a hammer to punch the nuts down, hopefully without damaging anything too much. And then I got to get the nuts out of the pockets, which my pokey bit's out here. The pokey bit. So one out. So all I'm doing here, two out, is pushing the nut down back into the slot and then kicking it out to the side so then I can pull it out. So there's one piece into the discarded piece box. How am I going to get this one off? He's just spinning. Flathead screwdriver. PETG is relatively resilient. Okay, got that down. Got it out. And he is boogered beyond belief. Now, what I want to do is try and save that square nut. Oh, sweet. And the screw, if I can. One of these two is... Ow. That ow was the end of the screw got extremely hot. Me trying to work it back and forth and get it out of here. The nuts. God, I don't know which side is bad. I'm guessing it's the screw, since it started unscrewing just fine, which means the threads in the nuts was okay. But it's not. This is where that third hand would be super useful. I don't know. I want to be the first person with a third hand, but if said mutation happened, it wouldn't be all bad. Really? Really? I wonder if I have a... So what I'm trying to do here is get pressure pulling out on the screw head while holding the nut on the back from spinning, so I can spin and hopefully unthread the last little bit from the nut. So I think I just managed to take a bunch of threads off the screw. Come on. Ah! Got it. So yeah, the end of the screw is complete chowder. So he is deceased. Now the question is the nut any good, or did I completely chowder it as well in this process? If these were normal nuts, oh, he is chowder. Okay, so M3 is this container. Let's see if I have any. The kit came with spare nuts, so I know I have at least a few. I just don't know if I have enough to replace everything, because I need 4 new ones for the new parts, or for the new assembly method. I have 3. I wonder. So I have 3 spare nuts. I wonder if I have any more of those anywhere. So 1 for the one I screwed up. 2 for 2 of these pieces. I need 2 more. Let me go look in one more place if I have a few. Okay, I raided a different kit of parts. And I was able to find 2 more of those. And I also was able to find that screw. So these 2 are going to go into the damaged hardware bucket back there, along with that guy. I probably could chase this with a tap and fix it, but they're pretty well chewed, so I'm just going to replace it and not have to worry later. Hopefully not have to worry later. Let me put some tools away quick before I accidentally knock it off the bench and onto the floor. I've done that many a time. Depending on how tired I am, you get lots of interesting words. Okay, so put that in there with that. Yep, that's all that part's. So, I'm going to do the other side. That's still attached. Just saying. Okay. I wonder how I managed to strip that guy. Because in theory, it's just going back into plastic. So it's not like there was a bunch of, going into steel where going through the nut it was fine and then it rubbed on something and boogered the threads. And the threads aren't exposed, so I don't think that was it. There's a nut. Another nut. And another piece done. So yeah, I don't know how I managed to do that. I'm apparently just extra special that way. Let's just hope I wasn't extra special twice. Oh, I need to get a replacement bolt. I got the replacement nut, I didn't get the replacement bolt. And that's the last one. Okay. M3. Next question is, how long was it? M3 by 10s. What size are those? M3 by 10 millimeter. I have a few. Yep, that should work. Head's slightly bigger on these, but it's going on the outside of the frame, so it shouldn't matter. Now I need to go to Prusa's website and find out what piece... do I? 3 by 10s. So the way this goes together is you put a nut in the side like that, which the old pieces did not have. And instead of a zip tie going around the rod and holding it down, you just put a screw in there and it clamps it. Not exactly sure what length screw, so I need to go look that up. And I probably should someday, so that one's all prepped, order some more of these little 3mm square, 3mm M3 threaded 5.5mm square nuts, because I have no more spares. Nada. So, you know, in my next Prusa order, whenever that happens to be, I could just get a whole kit of parts. But I have plenty of all the rest of the hardware. I got tons of metric hardware, except for these square nuts. I don't know if McMaster would carry something like that. I bet they might. Maybe my next McMaster order. I will get some more. And then never need one ever again in my life, but I have them if I do. They're kind of nice for putting in 3D printed parts, because you just make a square pocket. And if you make it slightly undersized in one of the dimensions, they don't fall out. Okay, so there's all those. Let me wander over and see if I can bring up Prusa without crashing the stream. That might be fun. So, Prusa assembly manual MK3S plus. Assemblies, Prusa knowledge base. Seems like what I want. Mini, nope. MKS plus, MK3S plus, and this would be the Y-axis, I do believe. And it's thinking about it. Motor mounting, getting close. This is the bearings. Just tighten. There's the rods. Clips. Nuts. 3 by 10s. So they're using 10s in there. So these are 10s. And 10s do work, but man, that's kind of overkill. So let me see. I got 8s. I got 6s. 6 is probably good length. How many 6s do I have? I have... 6s might be too short. Yeah, 6s are too short. I'm going to go with 8s. There's 4 number 8s, or 4 M3 by 8. And hopefully I don't dork anything else up. I'm done with that tray. So everything else that I'm doing I think everything else I am doing is just a bolt on or bolt off, bolt on replacement. So in theory, I don't need any other hardware. So first off, I'm just threading these guys in loosely. And the next step is I gotta put what am I caught on? I need to put the heat. Actually, I don't know. I need to put this on. He goes like this, right? Check the picture, because there is a picture. So the doubles go to this side. Honestly, I don't know if it makes a difference, but that's the way they say to do it. Make sure that 2 bearings are on the left side. See picture. So this is my left side since it's turned around, and I got 2 on that side, so we're good. So I got to put the rods in, and I want to grease them. Or I don't want to grease the rods, I want to grease the bearings. I have not. Some people go super crazy. You know, ooh, too much. They'll take the bearings, throw them in acetone or some other solvent, dissolve out all the, usually it's referred to as just shipping grease, and then, you know, repack the bearings with new grease. I'm just going to put new grease in them, use a Q-tip to spread it around all the bearings and sort of smoosh it in a little bit, and then hope for the best. I've actually had a set of bearings dry out on a printer. So it was printing along just fine, then one day all of a sudden I started getting crash detected, and investigated, and sure enough, like the rubber had gotten dry and was sticking to the rods, and all I did to fix it was put a little sewing machine oil on it. For those that don't know, sewing machine oil is usually a white or a clear mineral spirit, or not mineral spirit, mineral oil. It's nice because it doesn't stain clothing, that's why they use it. It also doesn't really dry up and leave a residue per se. So, and if it's good for the fine mechanisms that are in most sewing machines. For those of you who've never taken apart a sewing machine, man, those are kind of, well, the older sewing machines, non-electronic, those are kind of mechanical marvels. There is so many cams and levers in there all sequenced together to get the stitch pattern right. And if any of that stuff binds up or is out of sync, it just sort of eats itself. So again, I'm trying to put this rod in perfectly straight as to not knock one of the bearings out of alignment. So one of these 2 bearings is a little bit kittywampus, but I mean, they still roll just fine. The reason I say that is when you move it, hear that sort of resonance, and also just from the amount of force I have to put on the rod to move it, that I know something is binding a little bit. Well, I guess this one's about the same, so maybe not. Okay. Now I'm just going to leave the excess grease on there for now. So the next step is to put these guys on. And they say to put the set screw towards the inside. So right now I got this tie upside down. Oh, I may need to loosen these. So put these on both ends. I'm not really worried about the position or the clocking at this point. Yeah, that one's too tight. I'll get that all aligned once it's back on the machine. I'm just getting it on the rod and in the general position it needs to be. There you go. So, again, 2 bearings to the left when facing the front of the machine. Since I'm on the back of the machine, 2 bearings go to the right. I want to be very careful not to rip the wire out of my thermistor. That would be bad. I do have a spare thermistor. I'm hoping not to use it. As far as I know, that one was just fine. Okay, so now in theory, it should just be a matter of putting all this back together. In theory. Now let me double check. Yep, up and on the inside. So that screw is up and it's on the inside. So I'm going to tighten these, which I say not to do yet, just to get the end of the rod flush to the end of the clip. So like so. And then I'm going to tighten the rod clip, or rod clamp I guess you'd call it. Like like so, and then I'm going to loosen these off 2 turns, and then everything is back to loose and floppy. The reason you don't tighten them yet is you need to get the spacing between these 2 right, and there's a little bit of slop in the mounting holes to allow that to happen. So come on, yep, that one's in. In. I'm tightened up. There. Moved towards me just a smidge. Oh, I over-tightened. No, I'm not going to loosen them up now. The reason I say over-tightened is I can see I cracked the plastic on these 2. I gotta learn not to tighten things so much. But not huge. That's attached. Oh, Allen wrenches. Not a huge deal. It will still do what it needs, and the next time I have to play with this, if they're still kind of horked up, I will just print out a new set before I do my maintenance. So again, I am tightening these 2. And I'm also going to retighten these 2. So again, I'm trying to set the length of the distance from this surface to this surface before I tighten this clamp. Those are relatively tight. Tighten this and stop before it cracks this time. Maybe. I just can't help it. I have to tighten it a little more. Loosen these 2. Loosen these two. And now the rod should be able to flop around a bit. Loosen these a little more. Now I'm going to tighten, really tighten this one. Tighten this one temporarily. And you can see here how big of a gap I have. So pull that to there. Put the first one in. Put the second one in. Make sure that's all the way down. Tighten this nut. Well, screw. Bolt. That's a great debate. When does a bolt stop being a bolt and become a screw? I do not know. Okay, re-loosen these. Like so. And like so. So this, this end's pretty locked in because they sit, there's a boss on the bottom of the parts that sit in that groove. So this little tab here, or the equivalent of it, pops down into the frame rail like that and locks it in side to side. So I'm going to bring this all the way forward. So this bearing has hit this bushing or clip, and now I can tighten down this side first for no obvious reason. It just seems to make sense since this is right there against that, so it can't move. Again, trying not to strip, smash, or distort any of the parts, which I am not very successful at. I'm used to screwing steel and aluminum parts together, not plastic. Then this one, make sure he still slides nice and smooth. Let's see where the grease ends. I'm going to pick this up first this time. Rotate. Always be really careful with the thermistor on the back. Not a fun thing to replace. Now you pull it all the way this way and repeat the process with the screws on this end. So I'm going to do this one first since the bearing's right there. Tighten it and then over tighten it because that's what I do. And you should not do. And then do this side. Make sure everything slides nice and free. Almost looks like I have a crack right there. But no, I don't. I may have made the plastic yield a bit. When I say yield, it stretched. So I may want to, once I get up and running, print another couple of these and just throw them in my kit of parts. So I'm just checking to make sure nothing binds. It does not. I'm happy. I'm going to put the belt assembly back on next before I deal with the heat bed to this, because that's a little bit more fun, not so fun kind of way. So my screw that goes to that. I need a ball end wrench. Otherwise it's near impossible to get to these guys when the belt is on. There's one. Now the trick, is getting the hardware started into this plate square. Since the belt wants to push the wrench off kilter, it tends to start the screws off kilter. And that's a good way to ruin the threads in the plate, or cross thread the threads in the plate, and that just makes for a not so much fun time. If they're only slightly cross threaded, which it, well, at least in my mind, is a thing, you can usually fix it by just running a tap through it. But if you really cross thread them and bugger them up, getting the hardware out can be excessively fun. And then once you do get it out, the hole is oversized, and you usually have to either drill it bigger and put oversized hardware in, or drill it bigger and put what they call a helithread, which is basically a threaded insert that's one side, a larger diameter on the outside and then a smaller diameter on the inside. I assume they make it for little hardware. I usually see them for larger things like automotive. I had to do spark plugs on someone's car because they had a coolant leak in their head that was bad enough that it was hydrolocking the pistons, and it managed to push one of the spark plugs basically out. You know, just took the thread on the spark plug, and there was so much pressure it just bent all the threads over. That was kind of cool. Well, it sucked for him because it was a lot of damage to his car, but it's kind of cool that I'd never seen anything like that before, and I got to play with helithreads to try and fix it. So, you guys can't see what I'm doing at all. You probably still can't see it because the angles are all bad. I tried. Maybe now. So I'm tightening down the back block. So there's 2 screws that hold the 2 belt blocks to this plate. I got them both started and they're not quite finger tight yet. I've also tensioned the belt a little bit, mainly because I had to squish the blocks enough to get the second screw in. It also helps align the blocks because they're under a bit of tension. Now I'm just going to tighten that one. And here's the part that I always suck at. There's a screw right down in here that squeezes these 2 blocks together to put more tension on the belt. I just never know what's enough tension. If it's too loose, when your plate goes back and forth, it has to, when it's going this way and it has to come back, it has to take all the slack out of the back belt before it comes back. So you'll come to a point, you'll stop, and if it's doing a circle where it's a continuous movement, your circles will become more oblong and sort of squares. So, and if you're too tight, you stretch it too much, if you're really unlucky, you'll bend the shaft in your stepper motor, or you'll pop, either the belt or some other part will break due to over tensioning. So I'm going to go with that and hope it's good enough. The good news is if you don't over tension, if you're under tension and you just need to tighten it up, it's not too bad. Sort of flip it upside down, loosen one screw and tighten another. So you don't have to dismantle the whole thing to do that. I'm going to go with that and hope it's sufficient. Okay, so back to this side. So what's next is I want to put the heat bed back on, so I'm not fighting that for the rest of the evening. Had I been smart, I probably would have taken this off earlier, but I'm not smart, so we'll just keep fighting it. And later when I find out I ripped off the wires to my heat bed, the internet can go, "I told you so." And they'll be absolutely correct. I even told myself so. So to put this back on, I'm going to do it off the back just because. You put one spacer right in the center. That's the reference point. And then you need the one, come on, the one flat-headed screw. And you have to very carefully set this whole thing, let's see it, like so, and get it started. So it's not tight, it's just enough to sort of get started in the middle. And then I can go around and get all these guys started. Now I'm going to have to recalibrate the whole bed, which is its own trippy little deal. So what I'm going to do for that, I'm going to pop one of my spare ones, or one of the originals, out of this bag. I'm going to tighten up the nylock to the point where I can still spin the screw easily, but it doesn't rattle in the board. So go till it's there, it's tight. So I'm going to back it off just enough until it can move. Then go grab my pliers, which are also out here. Put things away just to need them again. Take this little standoff and pliers and set it underneath the platen, and then tighten this down until it just touches. Repeat that for all the rest of them. So this gets me close as a starting point, and then I'll do the bed leveling utility to actually get it to the proper height. And that usually takes several rounds of put a sheet on, run the utilities, see how level or not level which corners is. It's nice the utility says, turn this screw this way, this many turns. So overall it's pretty easy. It's just an iterative process, so you have to do it a bunch of times. That. So these, I'm just getting them basically started, so I'm not running up against the nuts. I'm trying to finish them off. Actually, now that the back row is done, I'm going to rotate the entire thing and bring the print bread all the way forward. This back row, even though there's more space on this side, is hard to get at, so that's why I did it ahead of time. Okay, get my wrench and my lock nut. Until it's locked up, unlock it. Put that in there. Steel tools and magnetic beds are interesting to say the least. Yeah, that one's good. Now I can tighten that one up just a little bit more. Let's see if I can get this in. Oh, go up. Okay, there it's on it. Let's see if my stream is still alive. Yep, the stream is still alive. Any comments? Nope, no comments. Anyone watching? Somebody is. Someone popped in. Looks like 3 playbacks. It's a party. Tighten. Loosen. Tighten. So about 1/8 of a turn is how much I loosen the nuts up once they tighten up on the surface. And then I put the spacer in, screw it down until it's stuck, and then just loosen it enough that I can pull it out. And this should be the last one for right now. Tight. 1/8 to 1/4 turn. Okay, and then the center one, I'm going to try and not booger this time. It's a good wrench, and it's about 1/4 and 1/8 of a turn. You know, down till just lightly tight, and then about 1/4 or 1/8 of a turn more is all I'm doing, or all I did. This time I didn't strip the head out, so that should be good. Okay. And I'm gonna double check the back ones. Let's see if you can see that. I can generate enough power, it actually says the little welcome screen. I just find that entertaining. Definitely not enough power to run the heaters, but can get the electronics going. Just doing the same thing on the back again. Since I got it the bed more parallel, I guess would be the right term. That means these these points back here opened up slightly. I'm just trying to tune as much as I can. Before I put it back on before I do the actual calibration, because it'll just speed things up that much more. Okay, so I'm going to call that done for now. Next up, I think it's just hot end. This is all hot end stuff. Hot end. Well, there's one non-hot end part in here. I'll leave that to the end. Yeah, everything else is hot end. So, interesting bit to me was this was loose, as you can see. I was never expecting that to loosen up, but it did. I will need zip ties at some point here. Put that with that part over there. This back cover, there's 4 screws, not 3. The back cover should come off. Now, one of these parts, I seem to remember I boogered up the threads in it. Or I boogered up the plastic and had to glue the nuts back in because I didn't have a working printer. I couldn't print parts, but it was close. Nothing was distorted. It just sort of, when I put the nuts in, I over tightened them like I do and stripped out the plastic which holds the nut. Yeah, I'm having problems. Give me a second here. There, got one out. That one's gonna be last. Got the fan out. Got, I think this is the Pinda probe. And that's the stepper motor. And last but not least, hopefully it fits, the IR sensor. Before I do anything, I'm going to give this a tighten so it never comes loose again. I heard it creak. Time to stop. So this part I don't think changed in the revision, or since the S's came out. It's C1. So revision 1. So they've never changed it. So I'm going to set that to the side. Go over there. So next, I'm going to flake my wires and get the hot end assembly off, which is cutting 2 zip ties and not dropping the whole thing on the heat bed. 1, 2. Oh, the belts. The belts have to come off. Oh. Oop. Loosen. Is this the X? This is the X. Loosen the screws on the X-axis, like so. And then loosen this screw in the old version, which this is. Lets you put a little slack in this. And then I think I'm just going to take the belt with this assembly for right now. Just like so. And what did I do? Q-tip. Because I will reuse that Q-tip. So here's my hot end in all its wonderful glory. I will come back to that later. Those parts with these parts to that part, and instead I'm going to concentrate on the Y-axis. Excuse me. Ooh. So this one scrapes. Well, yeah, there, can you hear it? I mean, they all do it to some extent. that one seems to be worse. So I'm going to guess that is the cause of that issue. Like I said, or may have not said, I thought I said, from time to time I've had some weird noises when the Y-axis is running back and forth. So I sort of figured I had a bearing that was going bad, or probably more likely I knocked a ball out of it and didn't notice when I originally put this together. So I bought some extra bearings here somewhere, and I'll swap those out when I'm doing that work. First things first, I'm going to take the top rod guides off. I can't speak. Speaking hard. It's getting late. Ooh. I wonder what's for dinner. And there that goes. Next, grab, stuck it right in the grease. Okay. Grab my towel, pull my rod out, and we'll clean my rod, and set it someplace hopefully safe. Repeat that action for this side. I've not figured out a good way to clean. To clean the trapezoidal screws and nuts. The nuts, in theory, you don't have to clean ever. My screws, you can see where, it primarily runs up and down all the time and kind of made a mess. And I'm just going to gently twist and pull. There's one assembly off. Two. And all three. Clean off some of the excess grease. No, actually I'm replacing all that. Never mind. Grease on. Do I have any more empty trays? Not really. Screw. Two screws. Three screws. Now I need to go find Prusa page for this axis. This would be the X-axis assembly, I do believe. Because it has changed how these parts go together. So I need to get some other hardware sorted before I reassemble. Bearings go in at a 45 to each other. Hey, they didn't update the picture. I picked the wrong one. I bet I picked the wrong one. Seeing how this change was one of the major changes for this, I found it unlikely that they didn't update their instructions to the new flavor. Oh, I just lost a nut. I heard it hit the floor. You can't see my floor, but it is just covered in little shiny objects. But I lucked out. S plus X-axis. Yellow. M3 by 30. Yep, that's new. And I have to push. I need to push the old bearings out. So I'm going to reuse them. Assuming there's no obvious damage. Shouldn't be. They were working fine. So damage is the wrong term. No indications of failure, pending failure. I'm going to reuse them. So the end that the slot goes all the way out of, there's a ridge, so you can't get them to go out that way. They need to come out the end with, well, didn't have a ridge. There was this little plastic flash, but it cracked. The end with a trapezoidal nut. That's probably the easier way to put it. So here's number one. Put that right there. Start number two. There's number two. Put that right there. And I'll recover this hardware. Oh! Excuse the excitement. I think there's a square nut in this one. Yeah, it looks like there is. So how am I going to get that out? So, right there, ooh, got it most of the way out, is another square nut. And as you know, I am out of square nuts. So, and this was a revision B7. And the new one is R6. Why the numbers go backwards, I don't know. So there's the new part versus the old part. And the main difference between these two is this one had the tensioner going this way, where this one doesn't. So it pivoted the motor around this point, where this one the tensioner's here, and it pushes the motor straight in line with the belt. So in theory it's much easier to tension things. So the first thing I'm going to do is just a bunch of stringies. And the easiest way to deal with PETG stringies is a flame. Well, heat. Just sort of hit them real quick and they all disappear. You know, it's not getting it hot enough to melt anything other than the super small strings which have no thermal mass to them. So while they just sort of instantly melt and vaporize a little bit, the body of the part does not, because it still hasn't sucked up enough heat to do so. Okay, that's good and clean. So, how do I want to do this? I'm going to put the bearings in second to last. So first things first, I'm going to get the trapezoidal nut. Trapezoids. It's just a good word. So a nut, standard nut, regular nut, was down in this pocket. And it is not behaving nicely. It's close. Nope. And I got it out. I'm just checking out to see why it didn't want to fit in all the way. I don't see any obvious reason. Just had to push harder. Okay, so I got that one in, I think. Yep, that's in. Oh, I dropped something on the floor. Stream is still going. Ooh, at one point we had 2 people watching. That's a new record. And second nut goes right like that. So I am just inspecting the trapezoidal nut to make sure there's no obvious mega damage. If it was damaged, I ended up with an extra trapezoidal nut because I had one of my Z-axis steppers when I originally got the kit that was defective. But thankfully, or so far, and hopefully it will continue, I don't need to use it. So that will just live in my spare part kit until I need it. I fail. So you cannot put the trapezoidal nut in yet, because the trapezoidal nut holds the bearings in place. So that comes back out. Square nut goes into slot. And then I think I need a 30mm M3, which would be this kit. And I have some 30s. Sweet. Just a few. The one they show is a partial thread. So the theory is this can go from here to there and push on the side of the motor to tension the belt. And it looks like it's set up such that they try and prevent you from over tensioning it because you run out of thread on the bolt. So there you can see it start to poke out where it pushed on the motor. So I'm just going to back that off. Put my extra bolts away before I accidentally dump them out. Okay, bearing time. So give these a quick inspect. I'm gonna grab a rod. Very gently put them on. He looks and sounds pretty good. Next one, same deal. Yeah, no complaints there. I forgot to rotate this one. So what I'm doing is rotating them 90 degrees so I get both sets of balls, and then torquing them to the side a little bit so there's more pressure on the bulbs and running them back and forth and making sure the balls flow, I guess would be the term, correctly around the races. If there's a ball missing, or dirt or grit or anything in them, you'll feel it when you put the balls under load and slide them back and forth. So now I'm greasing the next set. Just squirt a little grease in there, and then using the Q-tip to sort of shove it down into the ball grooves. And then also lubricate the little lips on the seal. If they dry up, even if your balls are good, they can sort of, instead of sliding on the top of the rod, they can stick and pull like that, and then it jams on the rod. Now this goes into this guy, starting with this end, and you want to put them in such, the first one doesn't matter, but this, I'm doing it this way, and then the next one you want 45 degrees. So the row of balls on this one are this way, and then the next one it'll be 45 degrees off. Boy, that's tight. There it goes. So I just pushed it up against a smooth surface to get the bearing started. And there he's all the way down. I'm going to lubricate the next one. I probably have enough lube on the Q-tip for this one, but I'm putting like that much lube in each bearing. It's not a massive amount. Even that much, a lot of it's going to come out when I put the rods in. Basically anything that's not down in the little bearing races will come out when you put the rods in. So that side's done. This one, I probably could have put a little more in, but that will do. Okay, so this one I want to put like that. Again, I'm just sort of looking down the bores. I have the lower bearing, the balls are straight that way, and this one they're at 40, well, as close to 45 as I can get with my eyeball. And just make sure it's flush. So one bearing is there, there's a gap, and then there's the upper bearing. Now I can put the trapezoidal nut back in. As you can see, it covers up that top bearing and prevents it from falling out. Now this one, I definitely don't want to over tighten. If you do, you distort the trapezoidal nut, which puts way more friction on your rods, and that'd be bad, okay? I want to just draw! And then this goes on here like this. Oh. Lightly tighten these for right now. Oh, I fail. Wire's going in the wrong direction. So I'm pretty sure the wire needs to come out the bottom, which means this needs to go like that. So not tightening any of these screws up so that the motor can slide back and forth like that, so you can tension this, and then this goes right like that. I should double check the pictures. They have pictures of this for a reason. And the pictures say oh, here you go. Wires go out the bottom. So yep, I got that right. So now I'm gonna spin these down till they're finger tight and back off a half turn. Okay, so that side's done. Time to do the same thing with this side. There. It's not a good idea to have magnetic bearing rods, just saying. Okay, so there's the trapezoidal nut, and it looks pretty decent. No complaints. There's also a idler pulley in here, in this end. Take that out. He has a nylock on the back side. So there's that. 2 screws. There's that screw. And then here's the little idler with its bearing pressed in the center. Not really serviceable in any way, so set it aside. Pop the nuts out. There's one. And the more difficult one. There's 2. And bearings. So they come out the side that the trapezoidal nut was on. Just like so. Set him aside. Like so. So there's the old piece. Here's the new piece. I don't know if anything changed on this end. So, well, this slot here is not in the new piece. Not sure what that was for. So there's where the slot used to be. So yeah, I don't know why they had us replace this part. R6. Again, I gotta heat treat all the stringies. That looks pretty good. And we'll start out with checking the bearings. Yep, pretty smooth. It's almost like these rods are slightly undersized. They move much smoother than that set did on those rods. Yeah, that's good. Okay, set that aside. And we'll grease these guys. One done. Take our new part. They go in from the side with the trapezoidal nut because there's a ridge on this side. First one, doesn't matter which way you put it in, but I'm going to try and get it perpendicular that way. Just sort of get them nice and straight. Push them in like that. So what I'm fighting with is these little notches right here get started, and when they line up with this top surface, everything sticks a bit. Okay, so this one is oriented this way. I'm going to turn the next one hopefully 45. So now I'm checking. I can see the lower balls like that. Crank the... Yep, no, the upper balls are about 45 to it. That one went way easier. I actually pressed that one in too far. There. There it goes. So I'm flush to the top there. I'm all the way down on the ridge on the bottom. Bearing, gap, bearing. And now I can fight with this bottom nut. Oop. Well, he just dropped right in. But did he align? Nope. So I gotta fight trying to get this all the way back and in. Well, that might have done it. So this bottom nut here goes in a little pocket, and it's printed with an unsupported overhang. And the little stringies, I think, is what I'm fighting against. So trapezoidal nut, do a quick inspect. I don't see anything to be concerned about. Put him back on. First nut's easy, second nut's a little more rough. Bolt in, bolt in. Try not to over tighten. So I go until it just starts getting some resistance, and then another quarter turn. The good news is if these are loose, they're exposed, so you can just give them a little crank later. And then send your idler pulley. I'm going to put the cap on the grease before I accidentally make a huge mess. So the nylock goes in this little pocket in the back, which can be fun to get started. So I'm going to try... So I just threaded the screw in backwards into the nylock, and I can use that as a handle to get it started. And put it up against a flat surface, and push it the rest of the way home. You can also get pliers like that, but just flat surface and push, and that's good enough. So next up, idler pulley goes on the inside. Eyeball it straight. Put the screw in. Tighten the screw into the nylock. Now, the reason it's a nylock is if you tighten this all the way down, the pulley will jam because you're squeezing the part on either side. Ooh, that didn't sound good. And I just broke the part. Remember what I said about over tightening things? Yeah, I have an issue. Well, that might hose me for tonight. Yeah, I totally broke it. So I broke out the inside of that. So I just totally pooched this part. So I'm going to have to get another one printed. For right now. Well, crud. That one's dead. I could go back to the original. I just don't know what's different about it. I know they changed the design. No, I'll wait and get a new printed one. Well, that sucks. I sort of want to clean. I'm not. Goes back there. Put this one back there. Sort of balance it on the bearing. Okay. There you can see some of the dirt that came off the one. So I've done all I can do on these parts until I get that part reprinted. So just take this whole thing. What I can do is still work on this tonight. So here's the original hot end. Apparently I over-tightened this screw because it split the plastic on the fan housing. That's not good. Let's see if I can repair that somehow while I'm in here. Oh, the new Super Pinda comes with new zip ties. I don't have to dig out zip ties. Ooh, look at the dust buildup in the hot end. That's a bit nasty. Unexpected. Here's my old it's not a hot end. What the hell would you call this? Air duct. And you can see right here where I had to clip some plastic off because it warped due to the heat. Let's see if I can get this nut out. Sweet. So that goes to the blower screws. There's that. And that hardware there goes with the blower. And next we'll get Mr. Pinda. I don't know if this is not the Super Pinda, but I don't know if there's a different name for it now. So set that. There's Pinda hardware. Hey. I have no idea where that square nut came out of. Oh, it probably came out of the back. So there's Mr. Pinda, which goes with that nut, screw, bolt, whatever, right there. Take these screws out of the back here. 2. And now it just sort of disintegrates in my hands. So there's the door spring and screw. How is this? These two are probably next. Shoot. I was going to try and figure out where this was jamming. I think I can still do it. Come on. There. Flat nut. From where, I don't know. Sensor parts. There's the back plate. Now, is this the one I glued? No, I did not. So, other than replacing the zip ties, that's the one I glued. I don't think I need to replace this part, so I'm going to keep him sort of over there. So I had reprinted that one because I thought I had to glue some nuts in because I blew the plastic out, but since I didn't, so it says C1, this one says R4. I don't see any reason to replace this. One of these nuts came from right there. I know it did. Yep, I remember that from last time. It's a little loosey-goosey. These ones are in good shape. I'm going to put a little drop of super glue in there just to keep that part, and this one will go into the spare parts bucket. Oh. I'm just going to put the tiniest little dab of super glue gel right there and let that dry, just to keep that nut from falling out every time I take this apart. And the dab is small enough that if I do need to get it out, it just snaps off. So here is the fan, which goes with those fan screws. This support goes with those. This sort of goes with both. Here's the back bracket, and here's my wonderful hot end. So put this over there, this over there, and hot end. Let me grab some things. Hurrah! Found them all. So I got, these are the 3 last jams I had on the extruder. So I kept them because you can see where the jam ended. But you're not going to be able to see, but I can see right where the gears were at when it jammed. So I can line this back up and figure out how far in the jams were. So that goes in like that. And we'll pull that out. Magnet will come out eventually, just not right now because it's kind of stuck. my sensor out, so I hopefully don't damage it. Put that right there. Take the magnetic lever assembly out. Again, so hopefully I don't damage it. And then I need to get this magnet out at some point. Let's see if I can do that right now. Do they have a hole? Oh, they have a hole. There's a little hole in the back. Thank you for the hole. Well, I'm glad I'm replacing that part. Yeah, that doesn't hose me for figuring this out. Boy, that magnet's in there really good. I do not want a hammer on it. That would be oh so bad. But there, I got it out. I'm going to stick it on there just so it doesn't go off into a low Earth orbit somewhere, as things tend to do around here. That's going to be fun to get out. So that's the one. As you can see, I super glued it and took a soldering iron and did all sorts of bad things to it to get it to stay put. And I'm just trying to... There's a nut. And that goes with those two screws. The question is, will I be able to get that out? Maybe not. We'll come back to that. So, back to trying to figure out where this jam was. So, I take one of these, and I'm just going to Sharpie so that black line is where this thing got stuck. So it went in like that, and of course there's more plastic. Yeah, so right like that. So sort of see. It's like halfway through the heat break. And that one's a little lower. Oh, maybe there's nothing wrong. No, they're all sort of right where the heat break starts is where they are doing their goofy thing. So, set that aside. Finish trying to pick all the nuts out of this. So, the reason I'm picking all the nuts out is I got a new one. I also have a new one of those, so I got to pick all the parts out of him, which looks just to be a one nut. Oh, come on. Strong enough? It is not strong enough. I don't think I have any stronger magnets anywhere. Oh, 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 yes! So take that. He goes straight into this part before he gets lost in a low Earth orbit. Also, that goes into this part is a standard nut right there, which is being particularly uncooperative at the moment. That was another piece on here I had to glue in because it kept falling out. That's a nice tight fit. buddy actually printed these in polycarbonate. I think I mentioned that earlier because he lost part of his bed. So these should not warp or deform. So here you can see the new part, here's the old part, and that's the piece I had to clip off because it just sort of warped and was hanging down into the print path. So should never warp again. So this piece, screws are removed. I'll go into that bucket. This piece, just how much dust. I never thought to look for dust in these, but they're quite dusty. So I have that nut I need to get out. Ooh, this work? I mean, it's an M3 nut. Realistically, I have a lot of M3 nuts. I could just replace it. But the cheap half of me, I'm going to spend a lot of effort to get that M3 nut out. And possibly damage something more important doing it. But, nope, lucked out. Ooh, I had that in there pretty good. So, this one goes with that one. And then I need to get that flat nut out. So all the things here, that flat nut's worth its weight in gold because I have no more of them. And unfortunately, they do not give you a nice little cheater hole to get that out. Let me see, what else do I have for... Ooh, dental pick. That should do it. Get that down inside of there. Oh yeah. Oh yeah. Not a problem. So, on this part, magnets out, square nuts out for the pin to probe, 2 nuts in the back, and I don't see any other hardware. New versus old. Apparently they made some changes to the filament path and closed that up some to prevent jamming. It's interesting on here. I can actually see right here where the filament ran, it wore the plastic smooth. So I put enough filament through here that the filament was wearing out the other plastic. But that can go into the junk parts bin. So I'm using a bolt through here just to line up the nut with the hole. Put the whole thing in the vise, tap, tap, tap. I can put it in from the front side until it sticks to a magnet. So there, bolts, the nut is in. It's a nice snug fit. That sucker's not coming out accidentally. And I bet you this is the one that I glued in. Yep, there's glue residue on it. He is not threading on nicely, so I'm just going to go, duh. I should have just done that from the get-go. But I'm cheap. Okay, stainless steel. I'm cheap and I had a billion of them. There was no reason not to just swap it, but oh well. I'll swap it now. Okay, that's done. So again, put the bolt through. Let's get Get the nut started. On here, tap and tap tap. Got it down and in a bit. Probably what I'm getting hung up on is just the elephant's foot. There we go, nice and tight. Now I'm looking around. Okay, there's a square nut should have gone right there. I bet that's where this one came from. Yep. Double check. Yeah. So that's where that one came out of. That is all done. I got that piece. That piece goes elsewhere. I'm just digging through my box. Pin to probe. New snock. New motor. The rest of that goes elsewhere. Okay, let's just start swapping parts out one at a time. I already loaded him. That goes with that. So there's a new top cover. I'm guessing it has to do with the alignment. So they took this boss out, made that sort of a tapered countersink. Thinned the part up overall quite a bit. Is what it is. Not that impressive of a change. I wonder if they made that hole smaller to guide it into the rest of the part to alleviate some of the problems I was seeing where it was rubbing where it should not have been rubbing. Okay, so that piece is swapped out. Now we have the fan shroud, air guide. This is another one where the nut always fell out. So I put a drop of super glue in there, and as you can see, the little drop of super glue on the outside, you're still able to pull the nut out without destroying it. The glue is just enough to hold it. Oh, this is a much tighter fit on the new part. I don't think that nut's going to fall out on its own anytime soon. Yep, that works good. I got some super glue in the threads of that screw, so... Oh, speaking of that... Yeah... I cranked this screw down too much. I split the case of the fan. So I'm going to try and glue that back together right now. Wish me luck. So squeeze some super glue into the crack. Hold it shut until the... Now in theory, CA glue is set off by moisture. I may have that wrong, but it seems to help to set it to... No. There's too much tension on there. CA glue or super glue is not going to be the solution this time. So that one is just how it is. And that's how it's always going to be. There. So I'm just going through the parts right now and picking off any stringy bits I see and swapping over what needs to be swapped over. Okay. So the ball goes into the new bit, the little bit goes in the box. That bounce out. It did. Okay. So this is called the X end stop. I don't know where this goes. So I'll have to come back to that one. Here is the sensor lever assembly. It just has a screw and a magnet. So magnet's in. The screw is in. And then this threads in right there. There's not even a nut to hold it, just right into the plastic. And since this base piece that I'm screwing into is polycarbonate, I don't think those threads will ever come out. So, way too tight. You want this to be floppy. Totally floppy. I have totally floppy now. And now, I'll put this magnet back in. So that's the wrong way. You don't want it to attract. You want it to push the two parts apart. So, when you push on this, it always flips out. And then this ball assembly goes in just like that. So when the filament goes in here, it pushes that guy towards the other magnet, which then breaks the beam sensor, which is not installed yet, which I will put in right now. Because there's a little teeny weeny screw and I don't want to lose it. Polycarbonate, harder to screw things into. So the sensor's tight, but I don't want to over tighten it and strip it out, because I'm really good at that. Okay, so this piece is done. Let's do the door assembly next. It's more of just prepping it. I'm not going to actually put it on yet. There, the nut is out. Just because it's easier. Line that up. Edge of the bench. Tap, tap, tap. And there we go. The nut is in. No, it's not all the way down. It needs more tappity tap tap. Sure feels like it. Oh yeah, it's all the way in. Okay. So line these two up. Push the pin out of this one without damaging the bearings inside. Which is kind of hard because the end of the rod is domed. So it's really hard to get a purchase on it to push it out. So let me try it this way. So every time I push down on it, the awl wants to skitter off to one side or the other. So something with a flat end actually works a lot better. There's the pin. There's the part. I'm just going to pick this up with both its bearings, move it over to there. Actually, I'll put a little bit of lube in there since I have it out. Slide. Ooh. roller bearings. Goop a very small amount of lube in there. And put the bearing assembly right back in. And as it rolls and I push the pin in, it will spread that lube all over the place. So there, I'm done with that door. Make sure that pin is pinned in as far as it can go. Oh, too far. But I got all the grease off. So I'm trying to split the difference on this pin between the two ears. Okay. That's nice and smooth. Rolly, rolly, rolly. Set that back up there. Next piece is this motor. First take that off. There's quite a bit of schmoo. So I'm going to take a brush to that quick. Cleaned all the schmoo out of that. So it was grinding a bit. This side doesn't have as much schmoo, but it had a little bit. Take this piece off. Those aren't very tight at all. It's interesting, some of these are pretty tight still, and others are not tight at all. So that goes to this piece. So I either went crazy tightening them, or I didn't. So again, just go over this with some heat to take all the little stringies off. Especially in the path of the hot end and the filament. Don't want those goobering the works up. Most of that should be fine. So which way do the wires go? So this is the top. So yeah, it went that way. So where's my new one? Sleep. Wakey, wakey. Ooh, got two people sort of watching. There's the new motor. I can't speak anymore. So first things first, I'm going to wrap these a little more, just so they stay together. Band can go bye-bye. Set that right next to this motor. Transfer that part over. And put in the two corner screws. So I'm just using this top one to align things. And that goes in like that. That goes in like that. I'm going to crank them a bit more than the last one because they were really loose, like super duper loose. I was surprised how loose. Don't crack, don't crack. Okay, I'm going to stop there. At least try to stop there. Line the flat up to that direction. Take that piece out. The little E label, can I get that off? I think I might be able to. So the E was put on before the cable was assembled. The cable is now assembled, so I could have pulled the little connector off the end and redid everything, but no. Let's check the color code. Blue, red, green, black. Okay. At least by color coding on the wires, these are wired the same way. Yeah, I'll stay. So there is that piece. Oop. Put this guy back on. Just snug it. So the filament's 1.75 millimeters. So I'm going to take my 2 millimeter wrench and try and get this aligned straight in the middle of the filament. So what I'm doing here is putting filament in the path, like so, and trying to get the hobbed portion, well, they're both hobbed, but the filament portion of the stepper motor gear directly in the center of the filament. And I think that's good for right now. And I'll double check this once we fully assemble it, but just give that a tighten. There. That should be that. Now it's time for send your hot end, because I think I've swapped out all the other pieces. I have a bonus flat washer, or flat. Until I'm getting tired, because I don't remember where I pulled that from. So what changed between this part and this part? So on this side, they changed how the little ball bearing assembly goes in. I don't think that's a big deal. So the old one, you had to assemble it because this little point here locked into the top, where the new one pulls in and out from above. So you could pull it out and swap it with a new one. That might have something to do with the alignment of the path, because that's what they said they were improving. So that changed. And again, on this piece, you used to cover both holes in the ball bearing and the point, where the new one's just a little cartridge that just fits in a hole with no screws going through it. The little lever bit also changed. As you can see, they beefed up the end of the lever. So I'm wondering if they're having problems with this breaking. The back of this is solid through here, where on this one there's a hole now up against the motor. So I'm wondering if they're hoping that's some airflow cooling. That's the only thing I can think of. Why you'd make that change. This part's the same. That part's the same. Yeah. So this piece is PETG. It's Prusa Jet Black, I do believe. It's kind of a more matte black than the PETG that it was originally printed in. So neither here nor there, just different. So I think so. So I have an extra flat nut. Where did it go? So I don't think it goes in here. I put the one flat nut back in here. Or does it? Oh, I know where it went. So in this guy, for the Pinda probe, there was a flat nut. In the new piece, for the Pinda probe, there is no flat nut hole. Unless it got covered up in the printing process. Oh, I'm glad I checked. So during the print, the hole for the flat nut got completely filled with plastic. That could have sucked later. So now I gotta figure out how to open that up. Where's my X-Acto knife? Here's my X-Acto knife. So I'm just cutting the ends of the slot all the way back, and then cutting the plastic out. I'm not going to cut the sides because I sort of want them, because they will help hold the nut in once it's in there, hopefully. Threads in, it threads in, we're good. So that extra flat nut was for the pin probe. So that's done. This is done. This I'll use to wrap up my original. I lost my E3D sticker. I'm a little bummed about that. But if I ever need a spare motor, I will have one with an E3D sticker on it. So I'm going to go grab here's my original box with my surplus. Well, that's not really surplus. My extra Z-axis motor. Yeah, see. So there's my extra trapezoidal nut. So that one, when you spin it, every once in a while it jams. So there's some sort of little defect in it. And that drove me completely crazy trying to get my first prints to work, because it doesn't jam all the time. It'll print fine for a while, spin, 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 then all of a sudden thunk. And it won't spin in that direction until you go back the other way a little bit, and then it spins again. So playing with it was like, this is working fine. Why print? Why print? And then finally found that, and it's like, oh, okay, that makes sense. So now let's take this hot end apart and see what we can figure out. So the PTEFT, this guy, tube, the top of it's all chewed up. I mean, it's functional, but it's not in a good place. Let me grab my tools. So normally, the way you do this is you turn it on, let it heat up, and melt the plastic. Yeah, I'm not going to get this apart. But I can't do that. I'm just going until things are a bit tacky on the plastic front. There we go. PLA. Smells like waffles. There. That was not the spot where I wanted it to come apart, but oh well. You can sort of see down it. So looking down the heat break, it's nice and clean. I got some interesting white schmoo on the face of it, though. I must have had some very decomposing plastic on top of this heat block, and it sort of left a ashy residue. So that should be reusable, that should be reusable. Yeah, you can see where lots of plastic had come schmooing out. Get that 4mm screw out, or I think it's an M3 by 4mm set screw. Yes, I can. Next up, try and poke the heater cartridge out without destroying anything. Well, not destroying the heater cartridge. And there we go. So if you look at my insulation on the heater cartridge, I've actually nearly worn through it right there. I'm checking to see if I actually made it all the way through. No, I haven't yet. And that's because when it's in the printer, I had it routed under the heater cartridge, and when I brushed the nozzle, I was wearing right on it. So when I put this back together, I need to make sure I route it over the nozzle, not under, or over the heater core wires, not under. Okay, so that's cleaned up. I also want to check the resistance of that guy, make sure he's on, or has the correct resistance. I've been noticing my prints, or I've been noticing things where I think my hot end is running colder than it should. And I don't know if it's because that guy is bad, because it's not off by much. It's like off by 510C, I think. Just enough that if you put it at what the print should be, or the filament should melt at, it doesn't quite, you know, it's the extruder has to struggle to print it. Can I get this out? So, since I have it all apart, I should be able to just stick a multimeter on it, see what it reads before I put it all back together. So I'm heating this up to try and get the heater cartridge out. And it's going to take a lot of heat. So again, I'm trying not to destroy any of these parts because they're good spares. But I do have better parts to put back. Well, I have spare parts I can use. Some of them I have better parts to put in. Ooh, hot. Imagine that. That's hot. Ooh, hot. Okay. So here's my heater core. 20 volt, 24 volt. 40 watt. It's got a lot of printer schmoo. If this was just a nozzle, I just heat it up until all the schmoo decomposed and I'm just left with a metal nozzle. But since it's a heater core, I don't want to do that and potentially damage it beyond use. So, taking my hobby knife here and just scraping the big chunks off. I do keep a spare heater at all times. If you get a really nasty booger, sometimes you can rip the heater core wires out of the heater core, and then it's done. Good enough. Okay, continuing down this path. Ooh, he's still warm. Is it warm enough I can get the... Ooh, he's downright hot. Okay, that's in. But not hot enough. Flambe! Big pair of pliers. Big pair of pliers. Grab the block. Ah, there we go. Top to the left. So far I have not seen a reason why my plastic was jamming the way it was. Very confusing. I was hoping to open this up and be like, oh yeah, PTFT tube was pulled away from the heat break or something else, you know, painfully obvious. And that has not been the case. Now, that top section was worn, and that was one of the things that they were addressing was potential filament path jams. So maybe that was the cause. Yeah, so right there. Put that there to cool off. So the plans are, this guy I'm going to flambe quick. And when I say flambe, I basically put him on a fire brick, heat him up with a torch until he starts to get sort of red hot and all the plastic shoots out of him. And then when that's done, you can clean them really easy. Turn on my exhaust fan, because this makes a bit of smoke. Imagine that. I'll be right back. Actually, I'm going to get a slightly bigger torch. So this size torch is about perfect for this work. That little micro torch just doesn't have enough heat. Okay, all the plastic just ejected itself from the brass. And the brass just hit a dull red heat, so I am done. This guy, I already cleaned out all the plastic. I don't see any defects in them. So to reassemble this, I'm going with some different parts. So I have a copper thermal block from E3D, and I have a titanium heat break. And I'm just checking the bore. The bore looks nice and clean. The bore is basically slightly bigger than 1.75. So I'm using my... So that might help things a bit if that's the reason why this was jamming. I still have not... Nothing's jumping out as, oh yeah, here's why. So if we look at all this again, that goes in there like that. So it was jamming. Basically flush with the bottom of the heat break. And again, flush with the bottom of the heat break. And I lost the last one. There it is. And the last one, a little bit not flush with the bottom of the heat break. So it's basically where this guy necked down. And that's, you know, part of the smooth bore. So I'm wondering almost if it was overcooling. So okay. Filament was extruding, and then it did a retract, and it retracted back enough that it cooled and then locked onto the heat break. Basically my cooling was too good, or my heat break was too good. I did try printing at a higher temperature to free things up, that did not work. I'm looking down the bore of this just to see what the finish is like. It's a little rough, but it's not bad. This one might be a bit smoother. What else do I have for PTFT tubes and heat thermal brakes? So I got 2 extra tubes. Just looking to see which one. I'm gonna go with that one. Throw these in my container of spares. Yeah, it's pretty well boogered, but if you have a choice between boogered and broken, I'm gonna use the boogered. Now for heat brake parts, I have an extra clip. So this is the original Prusa thermal brake, and you notice it's missing a bit. When I was having that Z-axis problem, I couldn't figure out what was going on, but I was still printing, and I actually bent the heat brake, or that bit, heater block. It actually bent the tube, and then eventually it cracked all the way off. Well, I say eventually, it cracked all the way off when I tried to straighten it, because it was at a funky angle. So that's how I lost my first one. Now this one seems to be quite a bit bigger. You know, this filament falls down it. This one, that one's also loose. This one's tight. This one is also a bit tight. This one, he's not as tight as those. So what I'm playing with right now is these two are original E3D or original Prusa heat brakes, which I think have a slight design difference than the E3D heat brakes that those guys are. So this side is tight, this side is loose, like hot dog and hallway loose. So I think they counter drilled down to where the brake is, and that might be the reason why I was getting the jamming. It's because they expected a slightly different design because their cooling is better. The downside I found with that, when I'm printing, especially when I'm printing carbon fiber PETG with a steel nozzle, if it stops because it runs out of filament and then you turn it back on, when you try to swap the filament, it almost always jams and you have to dismantle the whole thing to pull it out. I think I have a new theory on how to fix that. It's just when it stops, it turns off the heater so everything cools. So you go and say, yep, I'm here, let's swap filament, and it preheats again. I think it just doesn't wait long enough, or I didn't wait long enough for it to heat up the entire path. Either that, or I have to lie to it and say it's ASA and just go with a higher temp. I wish I had whatever size this hole is reamer, because then I could put this in the lathe and run a reamer down it quick and make sure that inside surface is nice and smooth. Because if the inside surface is rough this way, so the scratches are going parallel to the bore, not a big deal. But if it's rough this way, you know, sort of perpendicular to the bore, that gives you more surface for the filament to squeeze into, cool, and lock solid. This one seems pretty smooth, so I'm going to go with this guy. So these two and these two can go back in my box of parts. I keep the busted one just as a reminder to myself to don't try and straighten these. It's just not worth it. So I'm going to put this back in just enough so I don't lose it. Same thing with this screw. So that's the bottom. Oh, I bet my Uzi What's It's cool now. Yes, it is. Grab a brush. So as you can see, the plastic just sort of turns to white dust, and you just hit it with a brass brush, and it's good for another round. Now the inside is harder to clean. There's a bunch of ash. Usually I just hit it with compressed air, and then I have one of these acupuncture needles. Pretty sure that's what these are used for. I think it came with Prusa for cleaning. You know, they're meant for poking goop out of the tip. But you take the back end with the spring, or the wound handle, you just do this number to the inside of the bore, and it cleans out any ash that might be down in there. That plus some compressed air, and usually that gets everything out of it. I've never had one jam or have foreign particles. In the nozzle after I've done that. So I'm going to set this one slightly different. I'm going to make sure that the heat break, the end that threads into the block, is at or even slightly below the surface, which puts a little bit more nozzle sticking out. I think before I had the nozzle pretty much like that, almost down in, with this sticking out. The downside with doing that means there's more path for the heat to flow. So heat's sort of like water or electricity, it flows. So it starts at the heater, flows through the block, then through the nozzle and to the tip. Well, the whole time it's leaking out. So it's going out of the block and this tip into air. And since the resistance is constant, this tip is going to be quite a bit cooler than this heater. So the more you thread this out, so if you ran this sucker like that, there's going to be a much cooler tip than if you did that. But again, I've been having these weird problems. I couldn't see anything that would explain them, so I'm gonna set up like this time. So the heat break side is flush. The nozzle is extruded, poked out, extended out about that much. Well, this is a 1.5 millimeter wrench, about a millimeter, and go with that and see how it does. Before I put the thermal brake back on, I'm going to put some thermal compound on it, if I can find my thermal compound. So, done with the fan, turn that off. Conductive foam, nope. Banana jacks, nope. Heatsink compound. So, I just have, again, Archer, Radio Shack, thermal compound, so that dates that tube. And I'm just going to spread it in the threads. That was way too much. Thermal compound works great. Damn, does it make a mess. transmission fluid, silicone caulk, they all sort of fall in the same category for me. You know, once you get them on your fingers or your hands, it just does not come off. You got this smeary, greasy feeling for a good long while. The other day, Clorox disinfecting wipes. I was replacing some processors at work and needed a paper towel to just wipe off the old goop before I pulled the processors out of the sockets so that the old cruddy heatsink compound didn't get into the socket and cause electrical problems. And amazingly enough, that took heatsink compound off. Like, right here, where's my isopropyl? Way better than I was expecting. So, see if that helps any. Well, it's not just isopropyl. Well, that does help quite a bit. Maybe it is. Maybe just a little alcohol is all you need to clean a thermal compound off. My one bottle of 99% isopropyl, I have not been able to find anymore since April. Every once in a while they have the 70% stuff in stock, but not the 99, or at least I haven't found it. I kind of wonder if, you know, there's a limited capacity for making everything in the world. And I'm wondering, you know, since everyone's been buying it up to make sanitizer, if the people that make it were just like, we're not going to make 99% because we can take that 99%, make 75%, and sell more bottles because, oh, math's going to be hard. That 29% difference, every 3-ish bottles of 99, I can make a 4th bottle of 77. So, oh, or 70, not 77. Man, some days math is hard. Okay, so I spread thermal goop onto my heat break, and now I'm doing my damnedest not to snap that off. So the heat break is snug into the heat sink. The thermal block, or heater block, is it's not snug, it's flush with the end of the heat break. The nozzle is screwed in and jamming those two together, so that is nice and firm. And now, fan goes like that, E3D goes up. It's time to reassemble some of this other stuff. So the reason I did this is I needed to know which side all the cables come off of, and they come off of this side, the fan side of the assembly. So first, I'm going to put my thermal block in, or my heater in. It's nice and loosey-goosey, which is a good sign. So I'm just going to hold it so the cables are draping the direction I want so I don't have to fight against gravity. And tighten that screw. My assumption is the center of the heater is the center of the hot spot. So I'm trying to evenly space this on both sides and honestly failing a little bit. Again, third hand would really be useful. I don't smear heatsink compound around the heater. It's going to get hot enough that I think that would just decompose and burn off. So I'm leaving that as is. And again, if I got this clamp down tight, it should not be an issue. But there's some goop inside the button head preventing me getting a wrench down in there. That was bad. That was very bad. Okay. So what I just did was strip the head on the heater bolt. Oh, yes I did. I could leave it and it'd be fine until I needed to get it out. And then when I needed to get it out, I'd have to dismantle this entire thing just to get it out. So I'm going to do my best to fix it now. So I'm putting it in my vise, which you can't see. And I'm not going to move the camera so you can see, because there's such a delay on the feed. It'd take me forever to get it back to the workbench. So I tried this, no dice. So we're going to try this. My goal here is to cut a slot for a screwdriver. So I cut a slot and then I'm going to try a screwdriver. Oh, yes! So there you can see I cut the slot in the head, the screw is out. Life can go on. It is a air compressor, 10 millimeter by 3.5. I have some of those. I have quite a few of those. That goes into the empty junk bin. So the downside with button head screws, which these are, is you just can't get a lot of wrench head. Typically the wrench head socket's quite a bit shallower than a same size cap head, and it's also a smaller size wrench. So I don't like using button heads for that reason. Oh, there. That stopped, thank God. But just due to where this is, you don't really want a big huge head sticking down that can catch on your print and everything else. There must have just been goop in that other block, because this one the wrench fits much nicer. There, it's super duper tight. So there you can see the wires are sort of draping off nicely. And now the heater, or the thermistor, I'm going to put in. So first thing I'm going to do is decide. So the wires come out of this on one side, just the way they're made. So I'm going to bend the wires over so they go over the gap, so they're not being pulled against the metal immediately. That goes in there like that. And this time, this is what I was talking about. I want these wires to go above, so this goes in like that, above the heater block wires. And again, I'm splitting the difference on the thermistor, assuming the temperature probe is somewhere in the middle. That may be incorrect, but that's what I'm going with. Actually, it's more than likely near the tip. So I'm going to have it, the tip just slightly in, and the back end just slightly poked out. And then this screw, it's tight, but it's not, I'm going to crank on it tight. Next bit, PTFE tube, just goes in. Yeah, notice how that's wobbly. So you want to pull up and push down at the same time. And then it's not wobbly. And just repeat that around the edges. Sort of twist. The goal here is to make sure this tube is all the way down, pushing hard against that thermal brake so it doesn't pull out. And then I bought some of these little clips, and those clips just prevent this ring from being pressed. Now if I did everything correctly, it should just fit right back in here. So there we go. The last piece of this puzzle is I'm going to put my E3D sock over my E3D heat break, or heater block, sock, heater block. It is getting late and I'm running out of calories, which is a funny thing to say, seeing how I'm massively overweight and need to lose some weight, but it's a certain point when I start getting a bit goofy, and it's because I've burned off all the easy sugars, and now the body has to work for the fatty sugars, and I get a little goofy. So that's my new hot end. He's all ready to go. Now let's start reassembling this thing. I'm trying to remember how this goes. It's been a while since I put one of these together. Prusa is a knowledge base for this. Introduction. 3S plus Y-axis assembly. Difficulty, very difficult. Yeah, did that, did that, did that, did that. Bondtech here, I aligned that best I could. Hot end parts. Hot end assembly. Oh, okay. So, I don't have the box, filament box. I got that little box, but these will work just fine. So it's actually time to put this bad boy in. To start with, it doesn't matter. It does a little bit. So, heater assembly goes in first. Next, this goes on, in theory. Take that out for now. I'm snagging up on something. I wonder, is there a new PTFE tube? So that PTFE tube is too long. The instructions don't say. Ah, I got stuck. But if you look at this, there's this little step right there where the old one, nope, that's this the old one? Yeah, that's the old one. For the old one, it goes straight through and out. So it looks like I need a shorter PTE tube. PTFE tube. So for right now, instead of dorking up, cutting off one of my good ones and finding out, nope, I'm wrong, I'm going to take one of the one I just pulled out, which is all chewed up anyways, pull that out, put this one in, and see how much I need to chop off. So there it's in. Sharpie. Can I get it to transfer the line? No, I cannot. It's all the way in. And I'm wondering if they did this to prevent the problem I was just showing, where people weren't putting in all the way. So it looks like I just need to remove, you can't see that, the V-groove. Let me see if I can cut that off right there. Oh, that stuff cuts easy. You know what? The inside of this tube is oblong as well. So even though the part that's chewed up is gone, I think I'm going to put a new tube in here. These should be cheap. I just need to get some more. So this end here is nice and round, but this end is sort of oblong like that. Oh, I should have checked to see if it fits, because then I can use it as a template for the new one. Nope, I'm still a little too long, so let's trim that off again. Looks like that would work. I'm still a little on the long side. And there we go. Yes. Bit of a chamfer on the end. Yeah, that fits much better. And just test it with some filament. So interesting. That's another change they made. So pull this one out. So there you can see the difference in length. It's not a whole lot. It's just enough. Yeah, it's basically the length of the countersink in the end that they were using to guide the filament into the tube. So I just put a very light countersink on this. I'm still going to go through pushing hard, pulling up on the ring, you know, as if the ring was what's holding it down. There's no reason not to do that. And he's in there good and tight. Put the little blue clip back on. Put this into there. And I'm still a little bit on the long side. Just going to freehand. Okay. Pressed air. Still too long. Just a smidge. There, that snapped in nicely. Okay. See one little PTF stringy in the end of the tube. Okay, I got it. PTFE is not going to melt with your filament. It's just going to plug up your nozzle. So I should just pull it out and blow through it again. But I'm tired, so I'm going to be lazy and not do that. Okay, so now it fits in that little groove. So that's another change they made. Instead of the PTFE tube going all the way up to the Bowden gear, there's a little stop right there. So trim down your PTFE tubes before you try and assemble this. Otherwise, it's going to be bad news. So I think this screw, no, that's probably too long. Is it this screw? Oh, there's a backing plate. Yeah, I can't do that yet. So instead, I'm trying to remember. So that goes like that. This goes down in there. Yep. Are these the same length? Yes, they are. Good, I don't have to pay attention to play. Which one of these did I pull out? So there's one. I'll throw that one across the room. There's two, and I already failed. I failed major. People watching, you know what's going on, probably are screaming at their screen. All one of you. One? I don't even know if I got one at this point. It's pretty late. Maybe one. Maybe none. I do not know. So anywho, take that off. Take that off. Take that out. And put these two screws in. Don't forget to put those two screws in. You can get them sort of in after the fact, but man, it's a pain. So that goes in like that. This goes in like that. Everything fits down nice. Get that pointed in the right direction. Straight straight back. Hold your wires up. And now I can screw it together. Go until you just get a little bit of a crinkle. Oop, too far, I heard a crack. So now make sure I can get in. I can, and I can. So the next piece that goes on, I think, is the fan. So there's a bit of order of operations here. Yep, I did all that. Did that? Oh, fan goes on later. Cool. So this assembly is what goes on next. And few pieces you need to route through here. So one of them is the IR sensor cable. So it goes from basically right here like so. And let me straighten that out. It was a bit crooked. Goes down somewhere through there. So he goes down that little channel. Oh, there's a channel. I forgot about that. And then out there. Make sure I got a little bit of excess slack. And then the other thing that goes through there is the wires for the motor. So I'm going to give this a couple more twists, like that, and then he goes down and out and through there. So the goal is you got to poke this down into that corner, so I leave myself some extra slack up at top. It might be a little bit too much. And the little curly Q pigtail there will keep the slack from going off into places it shouldn't. So this bolt up in the top corner can go in now. First I'm going to try and get that plugged in, and then pull on this wires to pull the slack back a little bit. Put this bolt in. Oh, all the way. Okay, that's nice and tight. And the next ones are those ones that I forgot. Inside of the fan shroud assembly. They're a lot of fun to tighten. That one's done. That's probably good. Also at this point I can pull out those two dead zip ties to put new ones in. at some point. I'll try and get this cable back in again. It likes to pop out. So now the question is, that's too much. That seems like a decent amount of slack. From what I can remember, there's plenty of length. Well, the Prusa one, there's plenty of length to get to the where the motor plugs in. And I assume this one is the same since it was made for this. So what I'm doing here is I'm just stuffing the wires back under this groove here to make space for the fan wires. So next up is Senor Fan here, and ooh, got some stringy bits. Find the arrows for airflow direction and make sure he's blowing into the hole. And it does the same thing. It goes into that groove, into this groove, and out the back. So again, I'm just sort of poking him down into the void. The void! Like so. And then the fan goes in like so, and that just sticks up. And I can put safety guy at work. We go a little bit crazy because there's no fan guards. The world is coming to an end. No fan guards. But that is the way. I like the Cyberpunk Prusa printer. I like that little sort of, they added a little boot on here and kicked the fan out at an angle. Does absolutely nothing practical to the cooling or the fan, or positively. I don't know what the right term is. It's too late. My brain fails. But it just looks cool. Okay, I just put that in the wrong hole. So we'll pop that back out. Drop it on the floor. Drop something else on the floor. Okay, that was a chunk of PTFE tube. I could care less. But that screw I do need. Got it. But anyways, it sort of kicked it out at a 45 or 30 degree angle. So the fan was sort of looking you more in the face when it was running. Practical reason to do it? None. It probably detracts from the airflow a bit because the air has to make a corner. But it looked nice. That's sort of the point of that project. Okay. I can't run T-handled Allen wrenches anymore. I really should call it a night, but I'm going to keep going. Okay, these screws don't over crank down. They will cause the fan to jam, and then you don't have a fan anymore. And they're just threaded into plastic, so they'll strip out. So the fan still spins nice and smooth. All the wires are where the wires should be. Except for, oh, so this got on top of the heater core wires again. So fix that. I think this little notch here is new too. Ooh, is that new? That would have been, which piece? No, that's the original piece, so it's always been there. But again, thermistor wires over the top, heater core wires, and I was going to check the stupid thermistor. Oh, let me do that now. So thermistor wires right there. Let's figure out what temperature it is. To degrees C because Europeans don't have our weird non-linear metric units or English units. Boy, I'm tired. Okay, and set this to 20K. So we're sitting at about 19C, and this thermistor is reading 92.2 kiloohms. So let me go find a table. Let's go, new tab. Prusa thermistor table. Crunch. Yep. Where is... So I said we're about 19C. Ooh, it's not the right chart. I know I've seen a table. Reddit? Well, that's YouTube. That's not what I want. Whoa. Control Shift T. Backspace. Other people. Thermistors are rated 100 kiloohms at 25C. So still looking. 100K resistor values. Maybe ref PDF 25C 101, close enough. So we're sitting at, oh, no, this one goes lower as it gets colder. Oh, I'm stupid. I have a spare. Just check the value versus the spare. Ooh! So the spare reads 110, 111, which agrees to the tables. The one in my hot end reads 97. It's low. which that would tell the computer that the hot end is hotter than what it actually is, because the colder it gets, the higher the resistance. So 113 at 19C. If I go back to that PDF I just found for RepRap, and I look it up in the table, 19 should be 132. Either way, that one's running NTC resistor calculator. Eh. You know what? These are E3D. Maybe I need to look for that. E3D. No, not ESD. E3D. Tell you how to put it together. Yep. I know I came across the table for this. It was in a Reddit post, I do believe. Thermistor table, E3D online. That sounds right. At 10 degrees, it should be... No, they're not close enough together. Saying at 10 degrees, it should be 208. Nothing good in there. Well, I'm striking out. Let me go grab another hot end. Here's a cheap China clone that I got with another kit. Let's see what he reads. $120. So I'm thinking that one is low. I'm going to swap him. And digging some more around, here's an official E3D hot end assembly. Never been used. That guy has a spare part. He reads 141. And he's slightly sunk in. So I think he's way low. This came from Prusa. I think this came from Prusa as well, but this might be direct from E3D too. Either way, I'm swapping out for misters. Because it's going to be quite easy to do right now and quite a pain in the butt later. So I'll turn that off. There. And tomorrow I'll find that post of exactly what I was looking for. Just slightly slack that off. Pull this out. It has MK3S label on it. Here's the new one. The wire is the same, yep. That is the same, yep. Okay, how do I want to get this one to bend? So I'm looking at the heater cartridge. I think I want to bend like that. Okay, that's in there nice and good. Well, at least I remember to do it now versus much, much later. Okay, now I'm going to put the sock back on. So I want enough slack on these that I can get the sock on and off without too much pain. So I think when I rebundle everything, I'm going to try and get that just like that. Okay, what else has to go on to this massive, massive assembly? This can go back, this can go back. Oh, I lost my snippers. Where they went? Okay, so that's on. The little side wings like to pop off. That likes to pull down, but for right now, I'll leave that together. What else do I got for parts? This piece can go on. So, unlike the previous design, this. So the old one is where? So the old one just sort of attached on one side, and this side just flopped in the wind. This one has a little winglet, I guess you'd call it. So it goes in just like that. Motor skills are failing. Yep, just like that. So this side is locked in by that 45 keystone type of deal. And this side's held in with a screw. That's good to go. Blower Pinda. I think I might do Pinda next. Both it and the blower sort of go out the same way. No, I think I want blower first. So for the blower, that goes with the door. That goes with the door. I'm calling this guy bad. I am going to find a table and make sure how far off these two were. Oh, I'm stupid. How long has that been open? Yep. So much for that one. And that was the better one of the two. Internets, why do you yell at me that I left my Sharpie open? I got one trick I can play. Maybe resurrect it. So a little bit of alcohol into the cap, and then just let it sit. So the alcohol is the solvent used in Sharpies, or something pretty close to it. So sometimes if you dump a little bit of alcohol in a dried out Sharpie, it will come back to life. And so I'm checking the alignment of the Bowden gear, and it's pretty dead on. I'm happy with that. So I'm going to tighten that before I forget. That piece tight. I actually probably can put the door on right now. No reason not to. So the door just goes like that. Bolt goes through this side. Oh, I didn't check my door for strings. There, string's gone. So supposedly the door was modified somehow to make it open more. Don't know. That's just what the note said. Okay, you want to tighten this one till the door starting to snug up, and then loosen it up just a little bit. I want this to be floppy. That is floppy. Where's the old door? The old door, this part's slightly longer. I mean, very, very, very slightly longer. And it may just be my imagination. No, it's about the same. Supposedly they changed something about the door. I don't see it. And then maybe it's the offset to where the pin is. And but anyways, bolt, spring, goes in this side, comes out that side, and the common practice is tighten it until the head is just flush. So the top of the head is just flush with the plastic. I'll call that good. Well, there's another hole right there. Again, I'm wondering if that was for airflow. Oh. Now I can put my protective cap over the top of my sensor. Tighten it reasonably tight. Oh, I failed. back off. I need my ball bearing assembly. So let's make sure that the flapper and it's in the right position. The flapper is quite flappy. Let's put my ball bearing in. That shit. I don't want to damage this sensor. So it's coming off yet again. Okay, sensor's off, screw is missing. Saw it fall down right here somewhere. Nope. Nope. I thought I saw it fall down. No, first things first. Okay, that filament guide's all the way in, and when I put something in there, it kicks the sensor as I expect. Okay, where has my little screw gone? I likely have a spare of it. I likely don't know where the spare is. A nut on the floor. A square nut. Where did that fall out of? Right there. Guess who's getting a drop of super glue? Glue. And again, I'm not going crazy. I'm just putting a little drop behind the head of the, so this is the pocket the nut goes into, and here's the end of the nut. I'm just putting a little dab right there, just enough to keep the nuts from sliding out of their pockets, but not really gluing the nut in, if that makes any sense. Probably not. It's late. Hey, it's right there. Oh, those watching at home, you can tell how tired I'm getting. I can't even see screws in front of my face. But I'm almost done, or I'm almost as done as I can get, because I am missing parts. So I now have my filament sensor ball that goes down into the gears. It moves nice and freely. It's not binding. So the end of filament sensor will work properly. Oh my god, you're out of filament sensor. So you put this back on. Try not to over tighten it. That is plugged in fully. There's nothing really that holds this on other than the wires. Neither good, bad, or other, just the way it is. I've never had it come off, so I'm not going to screw too much with it. So what's next? Super Pinda! Still haven't figured out where that goes. It may be part of the MMU. Could be, because I just couldn't find it anywhere in the diagrams. So I got my super pinda out. I think I was going to do the fan first. That seems to make more sense. So the reason I'm mumbling back and forth is I'm trying to figure out the order to best put these two parts in so the cables or the wiring lines up the best. Does that go that way? No, it does not. How does that go on? So this, I think it goes this way, doesn't it? Yeah, it goes that way. That can just go like that, and then the fan with the unfortunately broken screw, or not broken but split. That's the pinda screw. Goes like that. This one goes like this. Fan spins, and now I can work on cable management. I think I wanted to do that first, so that worked out good. Next up, super pinda. So this is the new shebang. Here's the old shebang. Same length. Cable quality, they're about the same. Tips are a different color. That's about all you can see on that end. The interesting bit's this end. So the old pinda is a 4-wire. The new pinda is a 3-wire. The reason the old one is a 4-wire is they thermally compensate. So as this heats up, the sensing distance change. So they tried to use a thermistor and software to correct for that. Whether it worked or not, it worked pretty well. I mean, they used it for a very long time. So now they spent more money on their sensor and got one where it doesn't need to be, it's thermally consistent. So either the technology changed in it where temperature no longer affects it, or they've internally compensated these things, and they've done it, you know, the people that make inductive pickup sensors like this, that's all they do. So they have a bunch of smart people that 24/7 they're figuring out ways to compensate these things better, and they can just do a better job inside the sensor than the pinda solution could externally. So I usually leave a little loop like that, slide that in there. There's absolutely no reason to tighten it up at this point, because one of the things you got to do when you put this whole thing together is set the initial Z depth, and I think that's too low. So like that, and just tighten it up a little bit just so things don't fall out. I like to leave a large loop. That way if I do need to adjust it or move it or whatever, I can. And I think with that, there's one other thing I can do. So I think these go this way. One sec. Oh, it's only 9 o'clock. I thought it was much later. Fans. Bearing assembly, alignment check, did that. Top cap, side cap, fan support, fan shroud, fan, pinda. Yep, I put that in right. And yes, these do So the way you route these through here makes a difference, and you want the non-grippy end to come out the top. So that way when you zip them down, they go that way and it doesn't get jammed up in the rest of the thing. So those are ready to rock and roll. Is there anything else I can do? This whole thing can just sort of live there. Just gonna get it away. I can put my fire brick away. I'm done with that. I don't think I'll need mega pliers anymore, or mega screwdriver. I will need minor pliers. I am done with micro Allen wrench, and I think I'm done with macro, which is 2mm. I think everything left is 2.5mm. That's all 2.5mm. That's more or less spare parts. Put this away. Put that away. I know where. Oh, there they are. So apparently, I'm not getting tired. I must just be getting hungry because I'm way too loopy to the time of day it is. I'm just shoving some stuff away before I make too big of a mess. Okay. I can clean those bearings. That's something I can do now. So the problem I have run into is, since I don't have another one of these printed out, I can't assemble it. You know, I screwed up. I broke that part. It is what it is. I need another one, so I got to do that. But that's going to take some time and a working printer, which this is not. So I got to find an alternate solution. I know people's, so I'll get that taken care of. But until I get that taken care of, I still don't know where this goes in the box of spare parts. I'm sort of at a stopping point. So I got a suspect thermistor. I have a old Pinda, which is inferior to the Super Pinda, but I'm still going to keep it in my kit of parts in case I ever need it. Did I get through down to the wire? Oh, maybe I did. Oh, yep, the wire's down there. So one theory on this is maybe it shorted out on the heater wires at some point because it was abraded. I don't think so, but who knows. They're not very expensive, I don't think. I just got to add it to an order. Shipping likely costs more than the part does. So I'm going to find a clean surface on this paper towel and polish my rod real quick. Oh yeah. Oh, more thermal goop. So that rod is clean. Set him. I don't make clean spaces left. Okay. This one is much more crunchy than this one is. under similar loading. This one's got some shmoo in it. There. And you can see the rubber shmoo. I'm happy with that one. This one, he feels a little rough. And this is all very subjective. Yeah, I'm going to say that this one is bad. Replace him. First though, clean all the stuff off of the rod. I actually bought enough bearings to replace pretty much all of them in the printer if I needed to. Thankfully I did not. I think it's just that one. High accuracy YTPs. Yeah, these are just Amazon or Alibaba specials. Is it better? Is it worse? That's that one. Can I see a bearing missing? I don't see a ball missing. Doesn't mean it's not. Hard to say. It might just be all in my head. But I am going to clean these like so. Probably should wash my hands quick. Be right back. The hands are washed, so I'm going to re-lube all these guys. What I'm doing is I'm just trying to spread the grease down into the ball bearings best I can. So I'm not so worried about greasing the inside of the plastic. I'm trying to grease where the ball bearings actually run. And a little bit on the lip seals. There's that. Call him done. Ooh, there's some shmoo. Next one. Ooh, much too much. This one's going to be well lubricated. Bigger the gob, the better the job. You can see some of the dirt that's coming off of this one. Wonder if that's just... That was not good for it. Yeah, I think it was just outside. Last one, which is the new one. With that, I should be done with the grease. I'll put that back in my kit. I think I'm done with the greasing. And if I don't torque them, they glide nicely. Say those two are done. That one is done. This can go in the trash. So what else can I do? I don't think there's much. This goes back when this assembly goes on the printer. These are to put the assembly back on the printer. This I need parts for. That's trash. It's left over. So I can go put this connector on the other end of the electrical wires, which is exactly the same as what I did on the printer end, only different pins. And there's no good way for me to get a camera over there, so you're not. I also have a new knob. So I can put that on the printer right now. So printer, old knob, new knob. Why they changed the knob? Don't know. They did. It's kind of nice having the multiple little wings to make it easier to do that. I think in theory, the Y-axis rod holders and that knob are supposed to be black, but I printed it out of orange, because why not? Okay, so this can go in the trash. This can go in the trash. This can get put away. These guys. And I'm going to hang on to this one, even though I think it might be bad. Let me... You know, it might be bad for this application, but there might be another, you know, A, I might have one go really bad and need it, and B, there's, you know, non-critical or less critical sliding bits where I might want to use that. You know, 3D printer, not a good idea, but if I'm just making a guide block for something, it might be useful. Yes, I keep my bearings in Christmas containers because they were cheap. Wait for them to go on clearance and I buy a bunch. So I think with this I'm calling it a day. Well, I'm going to go solder this guy on, or crimp and solder. But I can't get the camera over there. Oh, I didn't clean that up. Give me a second. Screwdriver. And I'm going to 220? 320. So this is the thermal heater block that I took out. And as you can see, there's quite a bit of crud. At one point, I tried to print what I thought was PLA or PET. No, I thought it was PLA. Turns out it was actually ABS. And it actually started to print. And then proceeded to turn into this giant ball on the end of the hot end. So a lot of this plastic in the crack of this heat block is ABS remnants that I never got out. So I'm just going to scrape off the big chunks. And this is 320 grit, so pretty fine. And as you can see, it took off most of the plastic, or all the plastic, without really digging into the aluminum too badly. I am making the block infinitesimally smaller than it was. But not by enough that's going to make a hill of beans of a difference. You can really see where I've dug into it with pliers and whatnot over the years. Years? Can I say years? Yeah, I've had this printer for a couple of years now. So before someone actually gifted me this printer, I have the parts for a Delta that I was going to build. Still haven't built it. It's in the project backlog. But I helped someone out with the project, and they're like, you know, they wanted to pay me for the project, and I was like, nah, I was just doing it for fun. Helping other people out with projects is about as fun as doing your own projects, with the added benefit of you don't have to pay for it. Someone else gets to fund the project. But anyways, they were apparently extremely grateful, and they're like, hey, I got you something. It'll be coming to your mailbox soon. And lo and behold, I got a Prusa printer. So since I've gotten this, I've done a lot of things with it that, you know, I knew a 3D printer would be useful, but there's been a number of projects where, you know, normally I just machine them out of my mill, and instead, you know, I just cat them up, throw them to the printer, and a couple hours later, probably not all that much slower than me machining them, especially on complex parts, probably quite a bit faster. Parts ready to go, and I could go do other things in that time. So, I really liked my printer. You know, even stuff like this where things are going weird, it's overall still still super happy with it. So I'm clamping the sandpaper in my vise, putting it in the crack, and then sanding the inside of the crack real quick just to try and get the big chunks out of the inside of the heater core crack. I don't know what the official term for that split is, but from now on I'm just calling it the heater core crack. So there we go. You know, it's still banged up and misshapen a little bit, but if I needed a spare heater block, it's perfectly functional. And now I'll just go back into the collection. So I have one brand new aluminum heater block and 2 used heater blocks. I helped someone recover their printer after they had a print go bad and turn into the whole bottom end of the hot end was one giant ball of plastic. And as part of that, he got a copper heat block and put that on, sort of similar to what I did. And so instead, you know, it was a serious big ball of plastic. He just more or less bought all new parts and put them in. It's like, hey, do you want this heat block back? I can clean it up for you. He's like, nah. You know, if you want to clean it up and keep it, fine. So that's where I got my extra one. So I think with this, I am done. I'm going to go do the electrical wires, and then until I get another part, maybe I'll get lucky and get it tomorrow. I'll give my buddy a buzz and see if he can do it. And you know, I can't reassemble the rods because they go into this part. I can't reassemble those rods because they go into this part. I can't put this on the printer because it goes on those rods which go into this part. So yeah, cracking this, that was not a good idea. But the bulk of it's done. It is what it is. I'll get parts, I'll finish it up, and then I get to see if it prints.